What up, what up? Welcome to the Chapter 2 review for Algebra 1, Pearson enVision Common Core 2018. This covers linear equations, slope-intercept form, point-slope form, standard form, parallel and perpendicular lines. So let's get right into it. I'm being asked to find the slope and the y-intercept of these three guys right here. Now, when I look at something like that, I think of this guy right here. I notice that y is all by itself. And slope-intercept form looks exactly like this. It says that when y is all by itself, the number in front of x is going to be my slope, and the number that's floating around is going to be my y-intercept. So I know there's methods that we could use for these problems that I could probably be a little cute, but I'm going to solve all of these for y, maybe combine like terms here and there, and get it to look like this. So I could say when y is all by itself, the number in front of x is my slope, and the number floating around is my y-intercept. The nice thing about problem 1 here, right? Let me just blow it up. The nice thing about problem 1 here is y is already by itself. So when y is already by itself, I can compare it to slope-intercept form, which is this guy. And I can say the number in front of x is my slope. So my slope is 6. M is 6. My slope is 6. And the number floating around is my y-intercept. The number floating around is not 5. It's negative 5. So problem 1, very straightforward. Problem 2, I'm going to have to do a little bit of work for this guy, but it's not impossible. I know those of you who understand this chapter well might be thinking point-slope thoughts, but I don't want to think those thoughts because point-slope involves you taking a number and multiplying it to an entire parentheses. So let's not think point-slope thoughts. Let's just say, let's get this number out of here, get y all by itself so that the number in front of x is my slope and the number floating around is my y-intercept. So in order for me to do that, I add 1 to everything, 1 to both sides. I'm going to add 1 to that 8.4, cross u out. Y is going to equal 3x plus 9.4. Again, I compare that, and I'll write it out because why not? I'll compare that to y equals mx plus b. Because when y is all by itself, the number in front of x is my slope, so my slope m is 3, and the number floating around is my y-intercept, so b is positive 9.4. Okay? Some of you might be looking at the next one and thinking, standard form thoughts, and that's not the end of the world. I have videos where I take standard form and use shortcuts to find the slopes and the y-intercepts and all that stuff, and even the x-intercepts. But we're not going to worry about that. Again, my goal for this problem and this problem alone is just to get y all by itself, and once y is all by itself, I can find my slope and my y-intercept. So, let's get y all by itself by getting rid of the negative 1/2 x that's floating around and the 2 that's attached. Let's add 1/2 x to both sides. That'll move the x value to the right. And by the way, if you were thinking standard form thoughts, it's not the end of the world. But this technically isn't even standard form because standard form's only allowed to use integers. So gotcha. Now I want to write that out so that it looks like slope-intercept form. I have a 7 and I have a 1/2 x that don't combine. So I'm going to put the 1/2 x first and the positive 7 second. Okay? This is going to be weird. I divide everything by 2, divide everything by 2, divide everything by 2. Y is going to equal 1/2 divided by 2. When you take 1/2 and cut that in 1/2, you get 1/4. 7 over 2 is just 7 over 2. You can write out 3.5. You can write 3.5. Nothing fancy about it. You just can't simplify that. But what I do have is I have y all by itself, which means I can compare it to y equals mx plus b. Once y is all by itself, the number in front of x is my slope, so my slope is a fourth. And my number floating around is my y-intercept, so my y-intercept is going to be 7 over 2. And I just found the slope and the y-intercept of 3 problems. Oh, fun! Oh, it looks so pretty. Looks so pretty. All right. I am going to move my face, and I'm going to graph y equals negative 1/2 x minus 5. What I have here is something in slope-intercept form. The easiest way to graph a linear equation is when it is in slope-intercept form, because when it's in slope-intercept form, as you saw from the last 3 problems, I can look at this and say my slope is negative 1 over 2, and I can also say that the number floating around, negative 5, is my y-intercept. So now that I have a y-intercept, I have a starting point. I'm going to take my y-intercept, which is negative 1,5. I'm going to go to my y-axis, and I'm going to put a dot at negative 5. My slope is negative, which means it goes down and to the right or up and to the left. This is my rise. That is my run. So I'm going to go up 1, left 2, up 1, left 2, up 1, left 2. When I run out of space, I do the same thing by going down 1, right 2, down 1, right 2. I have myself a perfectly straight line. So I'm going to draw a line through it using this marker here. And it's not perfect, but it's better than some of the lines that I've drawn before using these things. So I'll give myself a pat on the back. Oh, what's that? You guys use Desmos? Here, let me show you how it's done on Desmos. All right, to graph y equals negative 1/2 x minus 5, we're just going to type it in. Y equals negative. To do a half, you do 1, and then a little slash button to give you divided by 2. Move to the right, x minus 5, and there you have it. So we're looking for some key areas, the fact that our dot goes through 0, negative 5. It goes through the point negative 2, negative 4. It goes through the point negative 4, negative 3. You're looking for some areas that you can definitely tell what your graph looks like. So this is it. All right, good job, me. Thank you. Thank you. All right, next problem. We got standard form. So I guess I could use the concept of standard form to graph this, which isn't the end of the world. I mean, if it's standard form, I can look at that and find the x-intercept. I can find the y-intercept and give myself 2 points. Not a bad idea. But I'm just going to solve this for y and graph using slope-intercept form. That's what I'm going to do. That's what I like to do. That's what I'm going to do. If you would rather do this in standard form, then you type up standard form Nick Perich, and I'm sure I have a video somewhere. But I have to get y all by itself. Y is not all by itself. I have a negative 3x floating around, and I have a 6 attached. So I'm going to add 3x to everything, just like I kind of did in that very first slide that we did together. I drop down the 6y. Over here, I have a 3x and a 12 that don't combine. And if I want to make it look like slope-intercept form, which is y equals mx plus b, I'm going to have the 3x happen first, positive 3x, and then I'm going to have the positive 12 happen next. Am I done? No. I have to divide everything by 6 because 6 is attached to y. When you divide a number from both sides, you divide every number from both sides. Okay, so this is going to simplify to y equals 2x. Nope, just kidding. Y equals 1/2 x plus 2. I was looking at the next number and I jumped the gun. Don't want to do that. I can now compare this to slope-intercept form, which is y equals mx plus b. I don't know if I wrote this out in the last problem. I probably didn't because I wrote it out 3 times in the problem before. But what this tells me is that my slope is 1/2 and my y-intercept is a positive 2. So the y-intercept gives me a starting point. And that starting point is positive 2 on the y-axis. So if I want to add more dots, I use the slope to be my guide. So this is a positive slope, which means it goes up and to the right or down and to the left. And this is my rise, and that is my run. My rise is 1, my run is 2. So I go up 1, right 2, up 1, right 2, up 1, right 2. Or if I run out of space, down 1, left 2, down 1, left 2, down 1, left 2. Look at all those dots. Let's connect them, shall we? Let's. Now, if this is a multiple choice problem and you cling to Desmos and you want to use Desmos for sure, then you could use Desmos. Watch this. To graph negative 3x plus 6y equals 12, we're just going to type it out. Negative 3x plus 6y equals 12. Nothing weird to worry about here. Look for the x and the y-intercept. The y-intercept is positive 2. The x-intercept is negative 4, 0. It looks like I have a slope of up 2 over 4 or a slope of 1/2 because it's up 1 over 2. And there you go. All right. Good job by me. Another great job. Graphing in point-slope form. So this is what I am going to do. I am going to use the concept of point-slope form. We haven't looked at point-slope form yet in this video, so let's write it out. Point-slope form says if I have a point x sub 1, y sub 1, just any point on the line, and I have a slope m, point-slope form is going to be y minus y sub 1 equals m times the quantity x minus x sub 1. That is point-slope form. Okay? So from this guy, I can get a point and a slope. All right, so let's fill that in. There's my point, and there's my slope. All right. I have negative y sub 1 equaling to negative 4. So if negative y sub 1 equals negative 4, that means regular y sub 1 equals regular 4. Remember that. You're using negatives as part of your answer, and when you need to use negatives, you have to kind of think opposite land a little bit. Since there's a negative in the formula, I have to factor that in. All right, I had to hit the pause button, so I'm not sure what I said last, but where I was is negative y sub 1 is negative 4. All right, so that means positive y sub 1 is positive 4. That takes me to the m here. I think that's where I was last time when I had a little interruption. Let me choose a different color. M is the number in front of the parentheses. Well, I don't have a number in front of the parentheses, but I have a negative symbol, which means negative invisible 1. So my slope is negative 1 or negative 1 over 1. Last but not least, I have a x value all the way over here. I know it's not as lined up as perfectly as I wish it was, but I'm circling the fact that I have x minus x sub 1 matching up with x plus 2, which tells me negative x sub 1 is positive 2. So if negative x sub 1 is positive 2, then positive x sub 1 is negative 2. Now, what this all does is this gives me a point to start at. Just like the previous couple graphs, this gives me a point to start at, and that point is negative 2, 4. So I'm going to go to negative 2, positive 4. There's my dot. my slope is -1 or -1/1. So negative is up and over, up and to the left, up and to the left, up and to the left. So I'm going to go up one, left one, up one, left one, up one, left one until I have no space. And I can go down one, right one, down one, right one, down one, right one, until I run out of room. Now, the reason why, if you're wondering, like, why does he do so many dots? As you can see from this pen right here, it doesn't draw the best lines ever on the planet. So I want to make sure that if I do draw a line, it's pretty good. So I'll take it. I'm like the tattoo artists for math. I need a nice little stencil in order for me to draw my clean lines. And that's a pretty clean line. Like my language. So we could just graph in point slope form by typing it in. Y minus 4 equals negative parentheses x plus 2. Let's look for the key areas. We have a y-intercept of regular 2. We have an x-intercept of regular 2, which means my slope is -1. The key point that you want to look for is -2, +4, which it goes through -2, +4. And that's what it looks like. All right, 5 problems in, and I already have a location change. The first of many. These videos go on for a while. I'm still graphing. And in this case, I have an x but no y. No matter. If I subtract 2 from both sides, which I'm going to do right now, I'm going to get -2 equals x, or x equals -2. Now, when you have x equals a number, that is a perfectly vertical line. So I go to -2 on the x-axis, and I go perfectly up and down, nice and vertical, straight through that -2, and that's my answer. Dunzo. If it was y equals a number, it would be a horizontal line. The slope is 0. In this case, the slope is undefined. Up and down is undefined. How would you do this on Desmos? Just type in 0 equals x plus 2, and since there's no y attached, you are going to get a vertical line going through -2. So if I wanted to get x all by itself, I'd subtract 2 from both sides, so it would be x equals -2, and so you can see that vertical line going through -2 and nothing else. Wow, terrific. Now what? We are slowly loading, and we have a slope and y-intercept to find, and we have to describe it in real-life terms. So let's zoom in on this picture and try to understand what this picture is giving us. We have water use. As time goes on, more water is being used. Simple. This is linear, so someone turns on a hose and lets it run over like 10 minutes, and then more. Ridiculous. Wasteful. But we need to find the slope of the y-intercept. So let's do the easy part first. Let's do the y-intercept. It's the origin. Okay, the y-intercept is 0, 0. So we'll just say 0. The slope involves me taking any 2 points and picking those 2 points. So I don't know. I don't care. It doesn't really matter. Let's just pick 2 completely random points like those guys. It doesn't make a difference. It's a linear equation. You're going to get the same slope no matter what 2 points you choose. Now, you have to be careful here. I'm not just going to be like, oh, it's 1 because I go up 1, 2, 3, 4, over 1, 2, 3, 4. No, 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 no. Look very closely at the values on the y-axis. Every 2 tick marks, you go up by 10, which means every 1 mark, you go up by 5. So when I go up 4, I'm not going up 4. I'm going up 5, 10, 15, 20. So my rise is 20. Does that mean my run's going to be the exact same? Nope. As you look, every 2 little tick marks is 2, which means every single mark here is 1. So I went up 20, but I do go over 4, which means my slope is 5. Now, what does that mean in real world terms? Well, the y-intercept is where you begin. When time equals 0, it's where you started. So without having to write so much, we could just say that the y-intercept means I didn't use any water when I started this thing. Okay, before I even began, at 0 minutes, I used 0 water. What the slope means is my rise over run means my gallons over minute. So my slope is 5, and I'm using 5 gallons, because that's my y value, per minute, because that's my x value. So my slope is 5 gallons per minute. Write an equation in slope-intercept form for that line right there. Slope-intercept form exists for two reasons: slope and y-intercept. I can look at that picture right there and easily come up with both the slope and the y-intercept. Reminder that slope-intercept form looks like this. When y is all by itself, the number in front of x, that m is the slope, and the number floating around, that b, is the y-intercept. So I can find my slope. The numbers are normal by going up 1, 2, 3, 4 over 1, 2, 3, knowing that this guy is negative because it goes up and to the left or down and to the right. And so since I went up 4, it's negative 4 over 3 because I went left 3. There's my slope. My y-intercept is the point where my line goes through the y-axis, which is that guy right there, 0, negative 1, which means my y-intercept is negative 1. So knowing that y equals mx plus b, and knowing that m is negative 4/3 and that b is negative 1, I have the equation y equals negative 4/3 x minus 1. And that's that. All right, another location change. Write an equation of a line in point slope form using that table right there. I think the best way to handle this is we could use slope formula, but if you're given a table, keep in mind that slope, generally speaking, is the rise over run. In other words, the change in the y's over the change in the x's, right? It looks like the x values goes up by 2 every single time. So the change in the x's here is a positive 2. It looks like the y's stays exactly the same, so you're going to have 0, which means my slope is 0. Now, if we're writing an equation of a line in point slope form, it doesn't matter which point you choose. Let's pick that guy right there. I'm going to call negative 2, positive 2, my point x sub 1, y sub 1. Now remember, point slope form is the form y minus y sub 1 equals m times the quantity x minus x sub 1. There's my m. There's my x sub 1. There's my y sub 1. Just like a problem a couple minutes ago, I have an infinite amount of answers. I just happened to choose this point. I could have chosen each of those, and that would have been just fine. But I'm going to start plugging things in. Y minus y sub 1 is y minus 2. That's going to equal m, which is nothing, times, well, who cares? Because in reality, that could be like the Queen of England, rest in peace, living inside of that parentheses. It doesn't matter. If you're multiplying it by 2, you just get 0. So y minus 2 equals 0. Technically, that's point slope form. If you wanted to be a little clever and be like, well, if I add 2 to both sides, then I get y equals 0. And you know what? That is the equation of a line. And that makes perfect sense, because if you go back to this table right here and notice anything, you'll notice that no matter what, y is 2. So if you notice that immediately, you could just be like, no matter, I don't care what x is. Whatever x is, who cares? Y is 2. So my equation is y equals 2. This is going to end up being a horizontal line across 2, because if I were to graph this, right, I would get dot, 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 dot across 2. So y is 2 no matter what. So multiple ways that you can look at this problem. That's the way I wanted to look at it. So that's done, and that's done. You used $90 worth of paint for a school float. Good job, you. You should feel special that you have a problem based off of you. The amount of money you spend is given by that equation right there. So there's my 90, where x is the number of gallons of blue paint and y is the number of gallons of white paint. Graph the equation and interpret the intercepts. All right, so I have 18x, right, plus 15y equals 90. That right there is my standard form of the equation. Now it's asking me to interpret the intercept. So I'm going to do this problem differently. If I wanted to graph this, I could solve for y, but I've done that a bunch of times. The directions here are not only asking me to graph it, but it's also asking me to graph the equation and interpret. So not only do I have to come up with what the intercepts are, I have to explain what they mean in the real world term. All right, so let's do this. The way I find an x-intercept is I pretend that y is 0. If I pretend that y is 0, I get 18x plus nothing equals 90. So you're gone. So if I pretend that y is 0, I divide both sides by 18. My x-intercept is 5. Okay, I'm going to do the same exact thing with the y-intercept. If I divide, or if I pretend that x is nothing, then that leaves me with nothing plus 15y equals 90. Divide by 15, divide by 15, and 90 divided by 15 is 6. So my y-intercept is 6. Now you might be thinking, okay, well, yeah, you found the x and the y-intercept. How does that help you graph? Well, just like this. If the y-intercept is 1, 2, 3, 4, 5, 6, then I can put a dot there. And if the x-intercept is 1, 2, 3, 4, 5, then I can put a dot there, and I can draw myself a terrible looking line that looks like that. So there's my graph. Now, what does the x-intercept mean? What does the y-intercept mean? Well, the x-intercept means that y was 0. Now, what was y? Y was the number of gallons of white paint. So what the x-intercept means is how many gallons of blue paint you would use if you used 0 white paint. So that's what the x-intercept means. The x-intercept means I would use 5 gallons of blue paint if we used no white paint. Similarly, the y-intercept means you are pretending that x is 0. And so x means the gallons of blue paint. So this says you would use 6 gallons of white paint if we used no blue paint. Now, that's my graph. What would that look like with Desmos? Graphing 18x plus 15y equals 90 might be a bit wonky, but let's just see what happens. Let's just type it in. So, not that bad. If we have to hit zoom out, then we hit zoom out and we get a little clearer picture, but the x-intercept is 5. The y-intercept is 6. This is in standard form, so I can solve for that anyway. It looks like my slope is negative. Negative down 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 5. So the slope is negative 6 over 5. So everything that we need to know about this picture is right here. Fantastic. Fantastic. So the last problem that I did, I used this method because I wanted to be a little creative. Why not? This is the same exact thing. So let me show more steps here because I have more space. Okay, my job is to find the x-intercept and the y-intercept. I really didn't show a lot of work. So for this one, I am going to show a little bit more work in case you were looking at that and be like, what do you mean pretend that they don't exist? Basically, if you are finding the x-intercept, you set y equal to 0. Okay, 4x minus y, which is 0, equals 3, and then you solve for x. So since that 0 is there, I essentially pretend that the y doesn't exist. 4x equals 3. Divide both sides by 4, divide both sides by 4, and my x-intercept is 3, 4. Now for funsies, what that means, and if I were to go back to this previous slide, when the x-intercept was 5, I put a dot at 5, 0. Okay? Since I'm pretending that y is 0, y is 0. And if I get x equals 3, 4, then that means my x-intercept, if I want to go above and beyond, is 3/4, 0. How do I find the y-intercept? Well, in the last problem, the way I described it is I said, pretend that the x doesn't exist. Well, that's because we are making x equal to 0. So now I have minus y equals 3. So what happens here is I get 4 times x 0, 4 times 0, and so that x stopped existing. I get negative y equals positive 3, and if negative y is positive 3, then positive y is negative 3. So my y-intercept is negative 3. What does that do from a graphical standpoint? Well, x was 0, and y ended up being negative 3, so I have the point 0, negative 3. So the x-intercept is 3/4, also known as the point 3/4, 0, and the y-intercept was negative 3, also known as the point 0, negative 3. Okay, so a little double whammy. I can't talk today with the x and the y-intercept. Find the line parallel to the equation below and also passes through the origin. Okay, I can handle this. I need something parallel to that line right there. Parallel lines have the same slope. So what I need to do is I need to take this guy and find the slope of that guy. So I have 2x plus 3y equals negative 12. If I want to find the slope, then what I could do is solve for y. So I subtract 2x, like that. 3y is now over here. I have negative 12 and negative 2x. They don't combine. If I'm going to find the slope, I want it to look like slope-intercept form. So I'm going to put it as negative 2x minus 12. Divide everything by 3. And I get y equals negative 2/3 x minus 4. Why is this important? Well, I need the same slope as that guy. What's the slope of that guy? Negative 2/3. So the slope I care about is negative 2/3. Now I needed to go through the origin, so I can do point slope form, or I could just use common sense. If the origin is 0, 0, that means the y-intercept is 0. So if I'm thinking slope-intercept, which is y equals mx plus b, and if the y-intercept is 0 and my new slope is negative 2/3, then I have y equals negative 2/3 x plus 0, which means I'm not going to put anything else. So I'm done so. In between which months did produce sales see only 2 consecutive months of positive growth? Only 2 consecutive months. Remember, consecutive means one after another, right? Positive growth means it looked like this. So your positive growth, then negative. So I'm going to just label everything for funsies. Positive growth, negative. Barely positive, positive, negative. Positive, positive, positive. Oh, but this one has a trick word, and that word is only. I want in between the 2 months that only gives me positive growth for 2 months. So these are the 2 months where I get a P after a P, also known as a PP. And those months are December and February. Pardon my terrible eyes, but between December and February are going to be my 2 months of positive growth. This is 3 months of positive growth. That's not what I asked for. Now, it wouldn't be a Mr. Perich. It wouldn't be a Mr. Perich review without crazy hard ones. So if you can hang with the ones that I'm about to show you, you can probably hang with any problem that you can see on a Chapter 2 Pearson enVision Common Core 2018 test. Great. Find an equation of a line passing through 5.4, negative 5.1, and negative 6.371. If I know me, I just made these numbers up off the top of my head, not really caring what I would get, and forgetting the fact that I would have to do this at some point anyway. So, whatever. I see 2 points. The last thing I want to do is try to come up with an equation in slope-intercept form. If it doesn't tell me that I have to make it slope-intercept form, I'm going to use point-slope form. Point-slope form is y equals that's slope-intercept. Point-slope form is y minus y sub 1 equals the quantity m times x minus x sub 1. M times the quantity x minus x sub 1. I don't remember what I said. It's been a long day. I have 2 points, so let's label them. I don't have a slope, though. I can find the slope by using the slope formula. If you watched up to this point, you know that you can use the slope formula to find the slope. We did it already. What's the slope formula? Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Plug them in. Y sub 2 is 7.1 minus y sub 1 is double negative 5.1. The lights in this room literally just went out, so I'm in night mode. X sub 2 is negative 6.3 minus x sub 1 is 5.4. All right, that's a double negative, so let's make it a positive. 7.1 plus 5.1 is 12.2. Negative 5.3 minus 5.4 is negative, that's 6.3. Negative 6.3 minus 5.4 is negative 11.7. Kids, I have news for you. That ain't simplifying. Now, if you were to plug that into like a Desmos or whatever, which I'm not about to do, I have no pointing videos for this one, you would end up with m equaling negative 122 over 11.7. My gosh. Now what I need to do is I need to take the fact that I have point slope form. I need to take the fact that I already labeled some points and I have my slope and just put it all together. Y minus y sub 1 is going to be y minus, where's y sub 1? 5.1. So y minus negative 5.1 equals m, which is negative 122 over 117 times the quantity x minus x sub 1, which is 5.4. Now, since I'm running out of space and running out of sunlight and running out of time, I'm going to finish this problem off by making that double negative a positive. You can't see what I'm doing, but I'm waving my hands in an effort to say, there you go. There you go. The nice thing about Desmos is we can just type in pretty much any line, no matter what it looks like, and we're good. Now with this, we have a fraction, so I'm going to hit 1 and then the slash button 4. Once you're done with your fraction, you move to the right and hit y. Then we're going to have another fraction plus 1/2. Let's see what we can find. If we zoom in a little bit, my y-intercept is -2. My x-intercept is -0.5. So that's a little strange, but my slope is going to be negative up 1, 2, 3, 4 over 1. So my slope is -4. All right, so there you go.